This is the Amp Hour Podcast, recorded February 3rd, 2015, episode 235, with guest Matt Richardson, Raspberry, Risorgimento, Regent.
Welcome to the Amp Hour. I'm Dave Jones from the EEV blog.
And I'm Chris Gamble of Contextual Electronics.
And I'm Matt Richardson from Raspberry Pi.
Hey, Matt.
Welcome,
Thanks
Matt.
for joining us.
Oh, thanks for having me. It's great to be on.
And I think a lot of our listeners will also know Matt from his wide experience in the past of writing books and writing for Make and just kind of being everywhere on the internet. I mean, you're kind of like internet project dude as well. So it's good to finally have you on and see all your stuff kind of rolling into a single project now. It's awesome.
Yeah, absolutely. It's exciting. I've been kind of a Raspberry Pi fanboy for a long time, and I was kind of like all over the place. I was doing projects for all kinds of people, doing them for Make for other people, and kept turning back to the Raspberry Pi. And then, eventually I was like, well, why don't I become an official fanboy for Raspberry Pi?
So how does that work? So you're working for the so like it's a foundation, correct? Kind of run us all through this in case there's someone out there who hasn't heard of it somehow.
Raspberry Pi is a nonprofit foundation with the mission of advancing computer science education. And we do that by selling a $35 computer, a credit card size computer. And it's for, learning how to code. It's for hacking. I've only been a month now. I started at the beginning of January, so I've only had a month on duty, and I know a lot about Raspberry Pi from using it, but I'm still kind of getting the hang of what goes on the inside.
How many people are working there? Would you know?
Yeah,
I'm just curious.
I want to guess around 15 people full time.
Oh, wow.
Okay,
that's fewer than I would have guessed.
Yeah. It's quite a lean operation.
Yeah. Right, and then there's also we've talked in the past before about some of the manufacturing that's done. I think the CMs are used for the manufacturing stuff like that, so that kind of helps expand the empire, of course. But
that's probably all the people you would need. I wouldn't have expected more than that. That's probably double what I would expect, because you need a couple of people to work on the hardware, maybe a couple of people to work on the manufacturing side of things. Keep that on track, and then you need a couple of people as media or a media person, and then you need a handful of programmers. So, that kind of adds up.
Yeah, you have it kind of nailed down there. We also have a very large education department that they're helping to build educational resources and have classes for teachers to learn how to use Raspberry Pi, and just any kind of educational outreach. There's a lot of that going on.
Yeah, and that's kind of the interesting thing to me is that, the reason I thought more would be because just scale, right? So obviously it's happened quickly, but, there's we keep seeing news about, 2 or 3 million or 4 million sold now. Basically...
I think we're around 4.5 million right now.
4.5 million,
yeah.
Wow.
We had Eben, I recorded with Eben at Maker Faire 2 or 3 years ago, and I think that was like 1 million at that point. And so, just growth rate, that kind of... I always figure that takes a lot of people for that kind of thing, but that's great that it is staying lean like that. That's important for
absolutely
doing cool things.
What's your take on the concept of orphaned Raspberry Pis, for want of a better term? Because I think we've talked about it before on here, Chris, and it's talked about on the forum a lot and stuff like that, about people who rushed out and bought one because they're all the fad and they're cool, and it's like $35. It's like, oh, how can I not buy one? I'm just going to click. I'm just going to buy it now because it's such a compelling price. And then it sort of sits around unused, and they go, oh, okay, yeah, what do I actually do with it? There seem to be, in my experience anyway, there seems to be a lot of
to be fair, that happened with my Beagle Bone Black as well.
That happens
with all
yeah. It's a similar thing.
boards.
And you can say it's similar to any flavor of Arduino or anything like that as well. People just get them because they're, flavor of the month.
And there's no expiration date on the product, so anytime someone decides they do want to pick it up and use it, like I have some older Raspberry Pis that are, from the first generation, and every now and then there'll be some reason that I'll be like, oh, you know what, I can use one of those older ones to do this or put it towards that.
I think that's why a lot of people bought one. It's because, it'd just be nice to have it hanging around, just in case I need to, a really, high-end CPU to run something.
Yeah, I think there was a point where I was buying them in batches of 5 because I was like, well, I know I'll need them. I used to do the same with Arduino a lot too. Just I know I'll need them, so I just I'd rather have a stock. I don't ever want to have to wait.
That's annoying. That kills.
Raspberry Pis.
Yeah, that just kills your product idea enthusiasm, doesn't it? If you have to wait to get something.
Yeah, you don't want to have to wait for anything, and the tools I was turning to, I tried to stock up as much as possible.
Yep,
that's smart. That's experience, folks. That's
what tools are we talking about here? What things do you stock up on?
It was a lot of Raspberry Pis. A lot of my early projects were based on Arduino. It was and all the proto shields and proto boards attach on top to them. All those kind of make it easy for people to do electronics projects that I need. Those sorts of things.
What are the must-have? They're not shields, are they, on Raspberry Pis? Get it right, Dave.
They're called hats.
Hats?
Yeah, hats. It means hardware attached on top.
Okay, see, I've never heard that. I thought it was called something else.
So when the first Raspberry Pi came out, Adafruit, I think, were the ones who coined the Pi plate nomenclature, which went on the first generation. When we released the Model B+, which is the much more refined physical form factor of the Raspberry Pi, soon after that we released the specification for hats, which set out the mechanical diagram of how it should be, but also the EEPROM that holds information about how the pins are used, how that can be addressed.
Oh, see, I didn't know that. Is there a... Right, so there's a defined standard. You put an E2PROM on your hat board... And then the firmware on the Raspberry Pi is able to configure itself based on that E2PROM information.
Yeah, absolutely. The idea here is that it ought to be for someone who just wants to learn about how to connect sensors and stuff. We didn't want them to have to do too much to figure that out. They want to be able to pop it on and have it configured on boot up.
Although the Arduino thing is pretty simple, right? It's just what board you've plugged on there, so you just choose the library for it and bam. So what's the advantage of the E2PROM over that sort of manual system?
The pins do have to be configured, to be honest, I haven't dug into the whole spec yet myself. I'm hoping to be able to do that during my time at Raspberry Pi to kind of figure out how that works, but there's you may be familiar with on the BeagleBone, there's a sort of device tree and device tree overlay where you can kind of configure pins and set up how because they're all multiplexed and how they'll work together.
So does that mean that if someone outside develops hardware like a hat, does it have to get registered with the Raspberry Pi Foundation folks?
No, it doesn't. It doesn't need to be registered. You just can't call it a hat. You can't go out and say I made a Raspberry Pi hat if it doesn't follow the spec.
Right.
You can by all means go and create anything you want, and that it sits on top of the Raspberry Pi. If you call it a Raspberry Pi hat, we ask that it follows the spec so that people know what they're buying.
Fair enough.
Yeah. That's good. Especially for big marketplaces where there's a lot of beginners coming in. That's really good because that can cause a lot of confusion,
Well, because that screws you up totally, because if, this is like an educational thing, so if you've got a school that's got 100 of these things and they go out and buy 100 of these hats, the sort of the non-authorized hats, and then they, phone up and say, well, it doesn't work.
Yeah, that's a big problem.
Yeah, that can suck away all your resources because, they've used some third-party hat, which isn't a real hat. They haven't followed the standard, and that just screws everything up.
Yeah.
So when you were talking about having these kind of on hand and also Arduino on hand, stuff like that, can we go back a little bit and talk about some of your project history? Just kind of run us through some of your favorite projects. I mean, we're looking at this on mattrichardson.com, and people can go there as well. But maybe some of your favorite ones to work on.
Yeah, sure. So I think for me, I started. I think my first really big project was called the Awesome Button. And this was all inspired by the Teensy USB, which before the Arduino Leonardo had like its a USB human input device set up on it. The Teensy was the first one, I think, that was really easy to use, had kind of the Arduino development environment, but let you emulate a keyboard or mouse. And so I was using the Teensy. I put it into a Staples Easy Button, the kind you can buy that you hit it and it plays the audio. And I connected that to my computer. And the idea here was that, like, I was writing for Make all the time. I was seeing all these awesome things and awesome this, awesome that. And I realized in my writing, I kept overusing the word awesome. So the button, every time I put it, would jam in a new synonym for awesome. So that, like, Nano was talking about fantastic and incredible projects. And so I made that, and I kind of, like, showed it around. And people really took to it. It really got a lot of attention. And
I saw it at the time. Yeah, it's
it was amazing, and like, and then that was like one of my first really big projects that really took off. And I'm you're watching all these YouTube comments going by, and you guys know what YouTube comments are like, and
yes,
but there's something sort of like exhilarating about it and fun. And
at first,
it's
5 years into it.
It absolutely gets exhausting after a while, which is probably why my YouTube channel's like gathering dust right now.
Yeah,
fatigue from it, huh?
Yeah. And then I think the other one people know me from is a project that was inspired by me watching TV, and they were talking about like Kim Kardashian or something, or Sarah Palin or something, and I was like, enough, I can't listen to this anymore. And I realized that because at the time I was working on reading the closed captioning data that was coming off the broadcast. And I realized, well, if the programming is closed captioned, I can look for keywords that I hate, like Sarah Palin, Donald Trump, Kim Kardashian, and then send my television's IR code for mute. So it's an Arduino project that listens to the closed captioning and mutes the TV anytime any of those people are mentioned. Of course, you program in anyone you hate into it. And so I called that the Enough Already. And that was another one that like, and that people really took to that. Like, I think that was the first time an Arduino project was like covered by Us Weekly,
Oh, really? Wow.
There were entertainment blogs that were really into it. I don't know if it was Us Weekly or whatever, but like there was good entertainment crossover there. I remember like the New York Post called me and was like, so, what about Lady Gaga? Could this be used to silence Lady Gaga? And I'm like, yeah. And like,
local technologist says he can silence anyone.
Exactly. He kept pushing me. He was like, so can you talk more about how much you want to silence Lady Gaga? And I was like, I was not giving him any. I was just like, I'm sorry. Like, I know what you want out of your article here. I read the New York Post before. You're not going to get it from me. They ended up writing
evil,
up the project.
They're just evil.
The tabloids call you up. Matt Richardson finds alien, also hates Lady Gaga.
Right. Yep.
Oh man, that's hilarious.
Yeah, that was a fun project because I didn't realize how much that would like. It would. I was explaining to so many people what Arduino was when I was like talking to press about the project, because they just love this idea that you could put something together that does something so many people want to do. And so that was when that was probably one of the biggest like mainstream press projects I've done.
Yeah, and I mean it's good like that crossover stuff as well, where it's it is there's some popular culture elements, but also like artistic elements, and also just stuff that draws people into technology. It seems like that's a strong theme throughout a lot of your projects. I mean, I love technology. I love playing with technology. I like to stick the blocks together in different ways and see what kind of comes out of it. I've never been into the super nitty gritty. In fact, I start to get bored when I have to think too hard about how to implement something. It's my biggest weakness probably. And so I'm the kind of person who just looks at the blocks that are already made, let's say a library or a piece of hardware, and seeing how I can kind of attach it in interesting ways. Yeah. Yeah, that's good though. I mean, like, because a lot of the time that is that integration stuff. I think you were the one who told me about that. Was it Sketching in Hardware? Is that the one? Or
Yeah,
there's
yeah.
like, could you talk about that? Because I don't think we've ever talked about that on the show before.
Yeah, so sketching in hardware is I don't know the history of it, but it's a conference. Maybe 50 people get, or some amount of people are invited to it. I think maybe 50 to 70 people show up. It's a different place in the world every year, and it's people coming together to talk about their hardware tools that they use, the things that they make with it. So you see people from Arduino there all the time. I think when I was there, the BeagleBone was represented. The guys who did Space Brew, the platform for kind of connecting Internet of Things projects a couple years ago, was there. It's a great conference. I had a lot of fun there. You meet a lot of interesting people, and the idea is everybody has to give a talk, about like a 20-minute talk, and present what they're working on.
I think that's just interesting for a lot of people listening to this, because it's like sometimes it's easy to kind of dig into the electronic side of things and then forget that like there's also sometimes people that are taking what's the output of this, the stuff people are selling on Tindy or other places like that, the smaller pieces like that, and then integrating them into larger stuff, and that can can have big impacts on other future projects.
Yeah, and I should say that this whole idea of sketching in hardware, I think it comes off of the idea of sketching user interface design, which I cannot remember the guy who wrote the book, but the idea is that you want to, if you can work quickly, if you have the tools that can let you develop hardware quickly, then you can really refine your product really well. And so it's that's why Arduino is kind of like the perfect thing to show at Sketching in Hardware and talk about at Sketching in Hardware, because it's one of those things where it's like, oh, I have an idea for something I want to do, I need to make it happen now. Let's see if I can make it happen right now. And Arduino is one of those things you can grab to make that happen.
Yeah. No, I remember Jeremy Blum, who's been on the show before, he was talking about he would show up at like a hackathon and actually do hardware when everybody else is doing software. And the same kind of idea where it's like you're showing up with pieces that are already there, but you're kind of taking them and then molding them around an idea, and then trying to basically show the power of the technology there in order to actually output something interesting that a broader range of people that would understand. So I think that's really cool.
Right, and just like with software. Yeah, it's just like with software. It's just a matter of knowing the tools, knowing what's out there, what's available, and then just kind of like having the development environment set up for you however you need it.
Yeah. So does that mean for your that you favor certain types? So again, for people listening that are developing hardware and projects for others as well, or like smaller pieces for a larger integration. I mean, is there stuff that helps you out? Is it mostly libraries, or it also interface documentation, stuff like that?
Oh yeah, absolutely. It's like, when you go to a site that has like let's say an internet service that has this excellently documented API, that's such a draw for me, because I really rely on that. Same with hardware.
Oh, totally.
When it's really clear what I need to do, that it's such a draw for me to use that as a tool. It's critical for me.
I think it's critical for everyone. I don't think anyone wants to reinvent the wheel to struggle just to flash their LED or do something, just to get up to speed.
Yeah.
Oh yeah, you're right.
So your background also, so you did that, when I met you, you actually gave me a tour around ITP. Could you tell us about that a little bit as well?
Yeah. Oh man, that place is great. So yeah, NYU has a grad school called ITP. It stands for the Interactive Telecommunications Program, but I think ITP is a better word to describe it, just because it's a sort of a morphing program. It's not necessarily about telecommunications and not necessarily interactive. It was started in the late 80s, or I think maybe even early 80s, that the idea here is that blending technology and art to create something new and something interesting. So the people who are in the program are, some of them are engineers, some of them are artists, some of them are doctors, some of them are dancers. And really? The idea here is they all want to use technology in some way. And so it's a super collaborative environment, and the classes you take are really kind of they're. It's interesting the way the classes are kind of a flipped variety, where most of the stuff you do in the classroom is really about discussing how technology is used, and the outside the classroom is where you're really learning the stuff you need to learn. Because if you have a dancer and an engineer, in one class. How are you going to teach the material that's about like doing, let's say, drawing on screen or doing projection mapping or physical computing with Arduino or something like that? So, it's an incredible environment. It's a 2-year program. I absolutely loved it. I stayed on for another year as a research fellow, and got to hang out with all these great people, and I didn't want to leave. It's a fantastic place.
That's cool. And what are some other projects, other projects that came out of there that people would know about?
Yeah, so probably the most well-known project that I did while I was at ITP was the descriptive camera. The idea here is that it works just like a regular camera. You point it at something you want to capture, you hit the shutter button, but instead of a photo coming out, you get a text description. And in fact, the text description comes out on a little slip of paper on the front of the camera.
Thermal paper.
Yeah, yep, a little thermal printer. And I think this is an example of a project where I am putting blocks together, I'm literally taking. So one block was the thermal printer, and then I used a BeagleBone at the time with a shutter button. The other block was Amazon's Mechanical Turk, which, if for those who don't know it, it's just how you can basically pay humans online to do tasks online for you. So,
boo! So there was actually a human. There was a somebody under the Mechanical Turk actually.
That's what
looking
Mechanical
at the
Turk
image.
is. That's how you prototype. That's
Sorry.
good.
Yeah,
that's good.
No, my dreams of artificial intelligence are shattered.
You gotta, if you knew me, you knew that there's no way I could ever do any kind of computer vision algorithm that would tell someone that their hat looks nice and where did they get that tie and that sort of thing.
So what would the response time be between sending the picture and actually getting the text back, having somebody in India look at the picture and go, "Oh, that's a hat"? Sorry about the accent there. I have to add the Indian accent.
So with Mechanical Turk, the API lets you put any price you want on the job. So if I put 10 cents on a job, it would be about 10 to 15 minutes. I put 25 cents on a job, it would be maybe 10 minutes. When I was demoing it for my instructor, I put about $2 on the job and got it done in a matter of seconds, I think.
Oh wow! Right. So it's like a bidding back end as well, so that.
Yeah.
Wow.
Yeah, absolutely. I think it's that service is still going.
No, it is. Yeah, I've talked about using it for stuff before for program or for online.
It brought up a discussion. I think it was with Steve Hofer. He at the time it came out, and he was like, "Well, it's an interesting thing to think about. Like, if you have a robot, let's say that it's autonomous in some senses, and it gets to a point where it's not sure what it should do. Is it about to go over a set of steps, or is it about to approach where it's supposed to be?" There's a possibility it could take a photograph and send it off to ask anyone out there to tell me what I'm looking at here and how I should proceed.
Right. No, and I think it's even broader. Like, it's just there's so much that technology can't do right now that I think that it actually. I mean, the time is definitely a limiting thing for that, but
right.
Even when you're prototyping things, there's so much where like Dave, you've talked about this before, where you're like at a trade show and you're the guy behind the booth, like flipping the LED, right? That's
right,
the same thing.
Yeah.
That's the Mechanical Turk in this situation, and it's really just a matter of. For prototyping, it's just there while you can't, you don't have the technology in place yet. You can just fake it until it's ready, that kind of thing. So I think that actually is really powerful. I think the interesting thing with it, though, is that you can get variation in the results, right? If you took the same picture if you took the same picture 5 times, you would get 5 different things, right? Because you probably have different people describing the picture.
It depends on how complex it is,
Right. And one of the ideas I had down, and when I thought about taking this project further, was just like, Instagram has different filters, or even just an actual camera has different filters you could put on it. That there would be maybe a switch on it that would say, I want poetry, or I want prose, or
nice.
I want comedy, or I want something deep or dark, kind of set the mood of the text. And then that could then go to the appropriate person. And by the way, when I made this, I was using Mechanical Turk at first, and I got accepted into a show where I was going to be showing it and demoing it. and it was going to be like 3 or 4 hours where I was going to be taking pictures. And it's like, well, there's no way I can use Mechanical Turk. It'll either be very slow or very expensive.
Yeah.
So I like leading up to the show, I cobbled together a PHP backend so that I could have my partner who was at work just getting every single photo himself. I don't have to pay him.
Right.
And so I just everything went to him over IM. He replied and it came right out of the camera really fast.
Nice.
The benefit of that was that my partner is the funniest guy in the world I know, and it became really fun, and people got a huge kick out of it because the descriptions they were getting were like totally off the wall.
That
And
definitely makes it better.
Yeah.
I was when you were talking about the different types, I thought you were going to say like you'd have different settings where it'd be like Frank or Susan, like the setting is the person it goes to, basically.
that you could do that. You could configure that any way you wanted. Yeah.
Still goes to show you cannot beat the wet computer, the human brain. I mean,
Right.
I was just looking at this the other day. Like everyone knows that the brain takes tens of watts of power. Right, it's like the whole human body's like 100 watts or something. Right, anyway, it's like in the order of tens of watts for all this computing capability we've got up here, and we can actually, if we really, really wanted to, actually match the computational capability of the brain today. But it would. People have done the calculations for this using our current hardware, the best available hardware. It would take, I think, 10 terawatts of power to match the computational. So how many orders of magnitude is that? I mean, so it's possible, but it's just the power consumption. It's physically the power consumption. That's how efficient the brain is. Sorry, I just wanted to throw that little...
No, that's interesting. I mean,
that little factoid out there.
I mean, Matt, so I've become a little bit more interested in the UI stuff recently, and I mean, I think that a lot of this stuff coming online too, just the dropping price of screens and computing and talking to screens, stuff like that. What's your take on UI these days, and especially like in projects like this or other stuff? Do you see it changing?
Yeah, I think what I'm seeing is that at least with coming from my perspective, and that's the world of places like ITP. People and where they're exploring with all kinds of different user interface elements from physical to virtual, the interface, we're using screens again a little more. I think that it kind of complement the physical as well. If you can get a cheap touch screen and a Raspberry Pi, that can be your user interface, which can be upgraded and changed anytime you want, and then that connects to your motors and your whatever. That's I'm seeing a lot of that. That's just because I think the price is coming down, and there's better tools for doing graphical user interfaces that's meant for that.
Yeah. Right. Exactly. Huh. So it seems
I like the switches and the dials personally. That's fun. But I could see a nice screen being a great user interface for a physical project.
Right. I can remember back in the 80s, we would pay an absolute fortune for GUI libraries, right? There was none of this, for free stuff available on the internet. There was no internet, right? And you would pay a fortune for these graphical user... for these graphical user interfaces running on these single-board computers, right? They were Intel, 8086 PC 104 boards, and you would have, racks of these things and all the I/O cards and everything. So it's basically similar to what we've got today. Same concept, but yeah, I mean, just the amount of free tools and libraries available today is just ridiculous. Back then, we would pay $10,000 for a GUI library, for the rights to this GUI library, so that we didn't have to write it from scratch, right? But that was cheap, because if you had to write this graphical user interface with, icons and pretty things, then, it'd take you forever. It'd take you, thousands of man hours or hundreds of man hours or something, and it's... So, you happily paid your $10,000 for your GUI library.
Yeah, and graphical programming is one of those things a lot of people I've seen get their start with programming, especially on the hobbyist side. They may use processing on their computer, to draw a line or something like that, and so it just like they carry that into the physical world as well.
Yeah. So I mean, and I think that it helps too to have a lot of these resources now for, like you mentioned, cobbling blocks together as well is I think that's a skill on its own, right? Knowing where to find stuff, then piecing it all together, and then kind of getting towards that final idea.
Oh yeah,
you've written,
knowing which block to reach for. That's what I use Twitter for. What should I use? I want to do this. What should I use? And then before you know it, you get all these responses.
Yeah,
Mechanical Turk for the in the public, right?
Yep. And then here's what happens. Sometimes is you're looking at. Let's say you say, hey, this is an interesting tool. This is an interesting block here. And you kind of put it aside. Here's another interesting one. How can I combine these together in some twisted way to make something that someone has never, ever seen before?
Yeah. Yeah. That is tough, right? I mean, the whole, making things that are unique is tough. Thinking about project ideation, that kind of thing is really difficult when you're starting out, especially. And,
it's all about the idea. And because the execution is so easy these days,
Yeah, well, especially GitHub and finding, sharing, stuff like that, right?
It's all about the idea, knowing what you want to do. And then, it's pretty easy to find tools to do it.
Right, yeah. And so if you find the tools first, then a lot of times it inspires the idea.
Yes, it does. Yeah, it is exactly. Just like the Mechanical Turk, right? You didn't actually do anything incredibly fancy technically there, right? You just bolted these things together and bingo, out popped the solution.
Right.
So,
right. Absolutely.
Yeah, it's great.
So how do you think of those new things, man?
Teach
me how to think.
I don't know. I think it comes from kind of having a sort of twisted, I don't know, I think most of the time when I've had an idea for a project I wanted to do, it really did come from knowing the technology first, or knowing what was out there and saying, hey, what could I do with it? So the Teensy USB, when I said, hey, this could act like a keyboard, what does that allow me? And, it was kind of letting that tool bounce around in my head and thinking about that while I was writing a blog post one day. When it hits you, it's like, oh, I just used the word awesome 3 times. I should be using the Teensy to fix that.
Right.
Yeah.
I actually really liked the that bike helmet one you did as well. I thought that was probably my favorite of your projects. The
bike headlight. So that was. I don't remember how that even came to me, but the idea there was that it's a dynamic bike headlight. It's a headlight that shines onto the ground ahead of you while you're riding, and it can display information in the beam of the headlight. So in the example I show, it's the speed of the bike, but it could show, maybe which way is north, or which, maybe it's navigation information. There's a Raspberry Pi project. It points the Raspberry Pi connected to a what do you call them? A Pico projector, and that had its own battery, and the Raspberry Pi gave a battery. I did some coding in open frameworks to read the speed of the bike and then project out the speed ahead of me as though it looked like a headlight. That was another case where I think at the time the way I came up with that was I was like, well, if I look at a Raspberry Pi and what it's capable of, and I look at a projector which has its own battery and is mobile, what could you do if with a projection and a mobile projection? And I think it kind of went from there.
Yeah. See, I would have done that a different way. If I had the idea for that, I wouldn't have used a Pico projector. I would have used a normal light, and then I would have stuck a transparent LCD in front of that. So then you could just, so then the light shines through the LCD, and then the shutter, the LCD shutter would generate the shadow. I don't know how well it would work, but,
I think
that'd be my
first.
Exactly. Yeah. But,
it's great. And it's fun to just try all that stuff out. Yeah. It's like if you, I don't know that on my site I have a picture of it, but I took the way this was a perfect example of me sketching in hardware, where I just screwed with one screw a Raspberry Pi to a piece of wood, clamped down the projector. I ran the wires, and it's all zip ties or cable wraps, and
duct tape, zip ties. Yep.
Exactly. And it was
and the problem with that is what? That's great.
I was able to get it out on the street and try it out and see that it worked, and so that's probably my best example of sketching in hardware. And then so like at the time I showed it to my dad and he was like, "Matt, you got to start patenting this stuff." And I'm like, "No, I don't have the patience. I don't want to make a product out of this. I don't want this to be the rest of my life. I want to move on and do something else." So if there's anyone out there that has the patience to make a dynamic bike headlight, by all means, go for it.
No, I mean, that's what I was thinking when I saw it too. It was like, oh, it's the kind of stuff where you expect to see. You expect the video to start with the person turning the camera. "Hey, Kickstarter, we're here today to tell you about."
I think I probably would never do a Kickstarter. I don't want to rule it out ever, but I don't have the patience and the wherewithal to go through with something that long. Yeah. I want to jump from one project to the next.
And trust me, it is as bad as you think it could be. Yeah.
I don't know, man. You've done books. Books are that's no easy
books aren't easy. Yeah. I can vouch for that too.
That pushes the limits of my patience. Is doing books. It's a grueling process.
Yeah. And like everyone else, are you going to say that if you're in it for the money, you're a mug?
Yes, I would say that. Although if I would give this piece of advice, that it's not it won't necessarily be the quality of writing and the all the work you do on making the diagrams perfect.
Oh yeah,
a lot of it's going to come down to what you write it about. So in the case of
and how you market it,
right? Yeah, but for me, the best-selling book still was the first book I ever wrote, which I co-wrote with Sean Wallace, which is Getting Started with Raspberry Pi. It was one of the first Raspberry Pi books that came out, and that
therefore everyone's going to buy it.
Yeah, that technology is just much more popular than other technologies I've written about. And that's just the fact. And I lucked out by being able to get the contract to write the book about it. It wasn't that I'm a great writer. In fact, there's a lot I wish I could a lot of work I want to do on the book now that the new Raspberry Pi is out.
Oh, yeah, right.
Yeah, I mean, I do tell people if I were to do another book, it would come down to just choosing the right subject matter that hits that it almost predicts what people are going to want to know about, and that's the tough part.
Matt, if you could predict the future, do us a favor. Don't go write a book. Just go play lottery or do if you can predict the future. That's right. That's a better option.
The Raspberry Pi one was just lucky. That was total luck on my part, getting on that gig.
Speaking of which, there is apparently a new Raspberry Pi. So I've heard. Tell us about it. Why should we get excited?
So the new Raspberry Pi, it's the biggest leap we've ever made in terms of performance. And if you're familiar with the first Raspberry Pi, it was a single core 700 megahertz processor. And depending on the model you had, it was either 512 megabytes of RAM or 256 megabytes of RAM. And we just announced, and we just started shipping the Raspberry Pi 2 Model B, which has a quad core 900 megahertz ARM v7 processor and 1 gigabyte of RAM. The performance improvement, they peg it at around a factor of six times more fast, but of course it depends on the application you're using, whether it's single threaded or multi-threaded, and it goes, the clock speed alone and the architecture of the processor means even a single threaded application is going to really do a lot better. Right. But then, there's some things that really scream on it now.
Yeah.
And the biggest leap forward is that it now uses the ARM v7 instruction set.
Yeah,
compatible core, right? Because that was apparently a huge limitation of the previous one.
Yeah, the previous one was ARM v6, and that meant we had our special Raspbian, operating system for it, and a few other operating systems that people could load on it. And now that we're on ARM v7, that means Ubuntu can be run on it, and already at release.
But I thought you could already run Ubuntu on it.
No, there's no support for ARM v6.
Okay. Well, how are people running?
Well, now that the Raspberry Pi 2 is ARM v7.
But everyone was running a version of Linux on the old one. So how did that work?
That's the Raspbian.
That was Raspbian. That was a Debian version of Linux.
Right. So it's actually a special build for.
Yeah, it's it's absolutely a special build based on Debian.
Oh, okay, right.
And now we're starting to wade into a deeper area with me when my knowledge of Linux builds. Anyway,
suffice it to say that. The people on the forum have been talking about this, and they say it can now run practically the same software any other ARM board can run.
Right.
So that's basically what it comes down to.
Yeah.
So if it works on some other platform, you'll be able to run it on this.
Yeah, there's very strong support out there for ARM v7, and so it's great to have that. I'm excited to see what robot operating system is
Right.
only
Yep.
supports ARM v7.
Ah,
I think
okay.
I want to see that.
Yep.
I want to see that on Raspberry Pi. I don't know how difficult that is to get over there, but I do want to see that because I think I love seeing people make robots with Raspberry Pi.
What platform were people using the ROS on before? Because it's, as you said, it's extremely popular. And what platform were they using?
I don't
to
know.
actually run that?
I don't know.
I just wonder.
Yeah.
I just assumed it was Raspberry Pi. I thought, the robot operating system runs on Raspberry Pi. Of course it would.
Is that the one that the Willow Garage guys were doing? Is that I forget about? I remember hearing about it, but I don't know who it was.
Every man and his dog's running the robot operating system to control their robot these days. It's the in thing. So they're obviously
Dave, I don't
haven't
have
been
a
using
robot
Raspberry
yet,
Pi. Well, nice. You need to get out more.
Okay, well. Yeah. So it's the PR2.
Anyway,
so that's Willow Garage, the PR2. I just looked it up. So
okay,
yeah. Okay. I don't know what the hardware internally to it is, but that's at least I know the PR2. Huh.
Sweet.
Well, that's
so they
that's
can now
great
run
though.
On the Pi.
Yeah, I mean, I think I don't know how difficult it is to kind of port those things over, but it's exciting that it's closer to being possible.
Yeah,
I'm sure someone will do it. Basically, if you build it, they will come.
Well, especially at scale, right? I mean, that's kind of the main thing. Is like just that's what's kind of different about this is scale around a single platform is bigger. Now, David was going to want to talk about PC 104, but
well, that was
but I think around a single
though.
vendor as well. I think that's very interesting. From a community perspective, right? That's kind of the big thing here, right? Is community.
Yeah, I mean, with 4.5 million boards out there, with all the support we get from various open source projects that want to be part of that, it means that your experience when you get a Raspberry Pi, the way I look at it is this: there's almost no technical question that exists without someone asking, can you do that on Raspberry Pi? And someone answering that question. So even the craziest stuff, so there, you can go out there and look and find that everyone is asking, can I do X with Raspberry Pi? Can I do that with Raspberry Pi? And many of these questions have answers. Sometimes it's no, you can't, but many times it's, well, yeah, you can. And here are these blocks that you need to make it happen.
Gotcha. What about so one of the things that I remember from the first version was some of the limited I/O output stuff, but then I didn't pay attention when the B Plus came out, or I remember the header got bigger. Could you kind of run us through some of the header stuff and what is output from there?
Yeah, when we released the B Plus, that was actually a big change physically for Raspberry Pi and the way it looked. It got the rounded corners, but the screw holes were finally in the corners, which were that was the thing. I don't know. It really bothered me that it had the squared off corners and the 90-degree corners, and the screw holes were all over the place. But the headers were now on a 40-pin header, which now all our models have. The Model A Plus, which is the lower end, which is the $20 version of the Raspberry Pi, has the same 40-pin headers, GPIO. It's got input and output UART, I2C, that kind of stuff. So that's kind of like our any kind of any attached hardware expansion board will go onto that 40-pin header now, up from I think it was 26-pin header before.
So is there no native SPI though? Is that the one that was not there?
I don't know. I don't know about that.
Okay. Because I remember, so I was doing a comparison of, a couple, I guess it was years ago now, but it was comparing just kind of BeagleBone Black and Raspberry Pi, and obviously you've written books about both, but it seemed like that was one of the things that was limiting, because I usually go for chips that are SPI because I don't like I2C for some reason. I don't know why. It's run more lines, Chris. That's smart. So yeah, I don't know what I didn't know if there was that in there. But I mean, you could always bit bang it, but then maybe then that kind of ties up processors and stuff like that.
My intelligence shows that the information I'm looking at, I should say, shows that there's one SPI bus.
Oh, there is. Okay.
Yeah.
Cool.
Yep.
No, that's good. I mean, and honestly, with high enough speeds, usually you're going to be pushing a certain amount of data over that, but you're not going to. You could always multiplex it on the other end if you do have, the right hat on there, or plate, or whatever you end up calling it. So yeah.
So you're informing me now because
Well,
I'm learning from you. 'Cause this again. I play with blocks.
Yeah, no, that makes sense.
Let's go through the issues on the forum. One of the big
Matt,
This
tech
sounds-
support for Matt.
tech support for the EV blog forum. Here we go.
I have no
one of
comment
the
on
big
this. I have no comment on this.
limitations of the Raspberry Pi has always been that it's not open hardware, right? It uses
Right.
the Broadcom chipset.
Right.
And that's still the case, right? It uses the BCM 2836 now,
Right.
apparently.
Yeah, we went from the 2835
Yeah.
to the 2836.
Which
yep.
you cannot even get a data sheet for. You have to
Right.
sign your firstborn child away to get a data sheet for
Right,
this
right.
thing. And is that
He was
has
going to
that
sign
been
Sagan
an
away,
issue?
but his wife said no. She said no. So.
It's a good question. I think what I remind people is that our mission here is to make an inexpensive learning computer.
Right.
Open source is great. We do a lot of contributions to open source software projects. We are open in a lot of ways. There's been a lot of work on the video core video driver to make that more open on the Broadcom side. We have to weigh a lot of options when it comes to creating an inexpensive learning computer. And, again, that has to be our priority, and how we keep it inexpensive, and how we give it all the power we need. And, so.
And all these pesky people who are thinking who want it to be more than you intended it to be.
Right. And again, that we love all the ways that people use Raspberry Pi. It's fantastic that it's not just a learning computer. It has become much more than that. It's absolutely fantastic. It's like a late speed, and, every time I'm reading up on something or we're thinking about a decision, the mission of our foundation has to come to mind first. And, that's really the priority. And so, for example, a lot of people ask, well, why is there no gigabit Ethernet, or why is there no SATA on it? And, again, it's got to be an inexpensive learning computer.
It's
I don't know how much
$35.
Dollars.
It's still $35. Honestly, I don't know how much people are going to learn better if they had SATA on the board.
I know. And on the
that's
forum, they're
interesting,
talking about why don't you support LVDS and TMDS LCD interfaces and all sorts of stuff. It's
Yeah. You know what? I think it would be a lot easier to create a board that had everything you want on it, I think, but our mission,
it's twice the price. It's 3 times the price.
Exactly.
It's,
Exactly. If you pull off the restriction on your price restriction on it, which ours is especially low, it's we could throw all that stuff on there. Sure. I'm sure it's tempting. And again, I can't speak for the engineers who make the decisions in Cambridge, but I'm sure it's tempting to say, yeah, I do kind of want that, but how are we going to make that work with with our BOM?
that must be frustrating as a design engineer. That must be. Yeah, that must just eat away at you, But there's other solutions out there. If you want higher power, you go for a Beagle Bone or an Intel Edison or something, right?
Or roll your own.
Roll your own. Damn it, you slack asses out there. Yeah,
And we talked about Bunny had that post about the Gankai phone and the MediaTek chip as well, and it seemed like it seemed like a similar trade off as well. It's like you can use and him and Zobs were hacking this chip to try and get at the register set and stuff like that. But basically, it was a trade-off. It's like you want this super cheap chip, you kind of have to. You're not going to get any support because there's all these commercial applications that are making it so cheap in the first place. That's kind of the same. It seems like a very similar kind of thing, and it's just kind of pick your poison. Do you want to be low cost and chase those parts that are in the super low cost region, or maybe more access at a higher price, kind of thing?
Right.
So no, that makes sense. I mean, that's good. I mean, that's good to acknowledge that trade-off is. It would be better if it's open hardware, but there's reality. There are realities in the electronics industry that we have to deal with. So,
if you want a higher powered platform, you go for an Odroid C1. It's $35, right, for this Odroid C1 platform, and it's and it's got better Ethernet capabilities and all that sort of jazz. If you're into that sort of thing, it's
right. Right, and then in that case, you give up maybe some of the community as well, right? That's
Oh yeah,
some of the other stuff.
Totally. You totally give up the community. But if you wanted some like real hardware to run some real grunty industrial stuff with, like the learning board oriented Raspberry Pi is probably not the platform for you. You want something else that's more tailored to that.
Yeah.
I sometimes don't understand what, when, people want all this performance. I'm not even sure what that extra, half a gigahertz is going to, really, how do people use that?
Well, in industrial applications, it's easy. Vision, for example, to do vision processing, that's a huge, big thing these days, and you need a lot of processing power. And even with the fastest boards out there, the fastest processors out there, you still can only do 640 by 480 at 15 frames per second or something. So people are really pushing for that sort of thing.
Right. And it reminds me of people who say the Raspberry Pi is not a good NAS because USB and Ethernet are shared. And I think, we're not trying to be a NAS here.
I know. If you want a NAS, go out and buy one. There's plenty of platforms out there. I know. Yeah, it's pretty dumb.
Yeah, but I'm happy that we have all these people also challenging us, and there's competition out there. It's great, to have other people. You look at some of these other boards; they look a lot like the Raspberry Pi. So it means we got to be doing something.
Yeah, no,
right.
That's true. Yeah, exactly. The right size and the right, a lot of the similar peripherals, stuff like that. I mean, and that's another thing that people give up, though, too, is kind of like, you think about it, you can go buy a rip-off of just about any type of hardware if you go to, Shenzhen markets, but what you're going to be giving up there, too, is, we've talked about this with, Arduino as well, right? If it's not an Arduino thing, you show up at a forum, you're like, well, I've got this piece of hardware, it's not working, now what? And then, is it actually, the right piece of hardware? Then you lose that, right? So you lose that kind of things. So that's... Yeah. And ultimately, I think that's going to be one of the things for, especially around education, stuff like that. So that's where Raspberry Pi is doing well.
Yeah. Absolutely.
So what are some of the things? I mean, I know you've only been there a month, but obviously you've seen it in the past with your past work with it as well. Are you seeing, or is the foundation seeing people doing a lot of? You said schools, but are there classes forming around it, that kind of thing?
Yeah, right. So in the UK, I think the Raspberry Pi has a kind of a good handle on the UK education system. Mm-hmm. Unfortunately, in the US, it's a little bit, it's not as cohesive. There's probably lots of different education systems, and at least 50, I would say.
Yeah, probably.
And probably even more. So what we need to do is kind of figure out how best are we going to, approach the US education market. And, so it's like how to do that most effectively is what I'm sort of been figuring out now. I've been just basically on the phone calling people all the time. Anyone who will give me time, who knows anything about the U.S. education market, especially when it comes to computer science education, talk me through it. What's your decision, when you're choosing what you want to do with your students? So we have in the UK, they run this thing called Pi Academy where UK teachers can go and learn about Raspberry Pi and connect with each other and be a part of the Raspberry Pi community so that they can kind of take it back to the classroom. We're figuring out, does that same format, will that work in the US? How can we pull that off? And what changes do we need to make? So, figuring that out now.
That's cool, though. So,
what age groups are you looking at there? Is this like high school?
Yeah. Oh, yeah. High school, middle school, even less than that. Even in lower ages than that. Because it's preloaded with Scratch, for instance. The drag and drop programming language, so it really lowers the bar for people to get on it and young people to try it out.
That's
Minecraft.
Awesome.
There's a version of Minecraft there, so
wow.
That's that's a great way for people to at least want to set up a Raspberry Pi, and then hopefully maybe they can explore beyond that a little more.
That's really cool. Yeah,
or just waste their life playing Minecraft.
There's some benefits to it. I think Minecraft's one of those weird things where it has these ulterior effects. That's not the right word. But basically, they're learning logic by building stuff up as well. I think there's some. There's been a bunch of interesting posts about. That's fine,
maybe.
But
I think there are some mods to Minecraft. There's people out there there's the mod community who use Python to mod Minecraft. There's a project that they want to do a Kickstarter soon called Piper, where you're learning electronics with Minecraft with Raspberry Pi. So yeah, I think like Minecraft
give me a bloody breadboard and some components, please. And then
well, you do, and so the idea is that you see the breadboard in Minecraft world, but you have to replicate it in the real world. And so for kids who their motivation to do something is Minecraft, and apparently there are a lot of kids out there like this. Oh, yeah. This is a way for them to kind of get in there. The project's called Piper, and I think they're going to be doing a Kickstarter in a couple weeks maybe.
All right.
No, that's good. Goodness. I mean, Dave, you and I have grown about it before, but like it's anything that brings people into the field is good, right? I mean, like ultimately, whatever it is, right? If I mean, like hell, if that Us Weekly article that you talked about, Matt, like if that brought people in, who cares, right? It's like, oh, Us Weekly readers, like, that's trashy, but right. But who cares? It's just about bringing people in. That's what's interesting, and
I'm glad there's lots of points of entry.
Yeah.
It may not be the tool for you or me. Like Minecraft isn't something that I'm particularly interested in, but I'm glad that people who that motivates, I'm glad it's there for them.
Dave's just upset because there's Minecraft players who make buttloads of money on YouTube just playing Minecraft.
Oh, no kidding.
100 times more than
Are they pushing are they pushing your ranking down, or
there we go? Yeah.
Right. No, they're just earning a shitload more than me.
Yeah.
For much easier videos.
Then you know where to switch to. Then.
Yeah, I know.
Well, in terms of bringing people in too, I mean, like that's one of the things I mentioned this before the show. Is like, I think Raspberry Pi is really interesting for me as well, because I see like, I talk to people that are like just computer networking people that just never would have even considered it. And even if, so out of the 4.5 million, say 1 million of them are computer networking people that never would have touched electronics, and of that 1%, maybe consider it, and then of that 1% actually do it, you still got a chunk of people that are still entering and trying things out. And like, sometimes it just comes down to numbers. And it can spread like that, getting more people interested in electronics.
Absolutely. I know that like so many of the people who I know who work in the world of web development have been asking me about all these different hardware platforms. The fact that they can, spin up Node on a Raspberry Pi or whatever is like, that's like they're in some kind of comfort zone there.
Yep.
And then they can kind of push that out a little bit, where if there's a library that lets them access the GPIO, okay, yeah, they made a something that tells them if the bathroom is open or not, and it's using some crazy JSON API and everything. Yeah. But that's like, it's so crazy to do that, but that's kind of like their comfort zone, and that's how they kind of like, find their way out in that realm.
Yeah, it's very top down. Like so we like many things, Dave and I have disparaged JavaScript based processors before, like and now I know the Tesla folks and stuff like that, and I talked to them about it, like, oh, what's the difference and stuff like that. And like between using C or using JavaScript on, I think it's actually Node running on like a micro, and it's like the time differences is huge, but when you put that in front of someone, it doesn't matter. You're getting someone in, you're showing what you can do, then they go, and then I think the people that are going to be optimizing anyways, eventually then it's like, C is your endpoint or assembly is your endpoint anyways, right? As you chase more and more perfection, and not perfection, that's a bad word, but just optimizing for that kind of stuff, you're going to learn, you're going to teach yourself a bunch of other stuff on the way anyways, because you want your robot to get out of the way in time, or you want your your vision application to do what it needs to do. So I think that ultimately is what it's all about, is access and bringing people in.
Yeah, absolutely. You use the tool you're comfortable with to get something done quickly, even if it's some phony prototype.
Yeah. Oh, definitely. So are you seeing? So in terms of like the community stuff, are you seeing? Do you get to like an inside view of like interesting new projects now? I mean, I don't know if you can tell us about interesting new projects, but like within the community.
No, I haven't seen, and no one's come to me with, that Piper project, someone came to me with that, and I thought that was pretty interesting what people are doing, the Minecraft electronics one. But I hear of ideas of people want to do. I haven't seen anything interesting yet. One of my favorite makers, Michael Newman, sent me a project that he had worked on, which was like an installation at UCLA Extension. It was kind of like, the effect was a panel that had 35 separate circular screens on it, but it was really just one large screen with like kind of a masking over it. And
Oh wow, that's cool.
It's a really neat project. I wrote it up for the Raspberry Pi blog because I liked it so much. And I just love that. Like, this is a case where people are using screens in interesting ways, and as people are upgrading to their 4K television sets, and they don't know what to do with it,
Right.
their whatever, their junky whatever set that sucks. They can put that towards a project or an interface or something.
Oh yeah. I definitely saw. I was like, when I got mine, I'm like, oh, I'm using all my HDMI connections. I don't know, and it's like those small things that just kind of like, oh, well, now I have to go figure something else out. I don't know, but that's what we have to deal with, I suppose.
But I think there's going to be a lot of great stuff coming down. A lot of people working on things. Where I'm working on some cool partnerships in the U.S. here. I'm talking to a lot of people trying to get Raspberry Pi out there, and I'm one guy over here in the States, and so if any of
you're the only one on.
Yes, I'm the first ever Raspberry Pi employee in the U.S. and
wow.
So I can use all the help I get. I can get partnerships or ideas, ways that Raspberry Pi can kind of get out there in the U.S. and how we can basically advance computer science education in the U.S. using Raspberry Pi. Let me know.
Oh yeah. We'll get your contact info at the end so that everybody knows how to get a hold of you.
So you're just working from home.
Yeah, I love it.
That's
sweet.
Great. So I want to hear a little bit more about the educational side of things. Like, so have you gone through the UK stuff, like for the UK Pi Academy stuff?
So I haven't gone to Pi Academy yet. The plan here is that I'll be making at least quarterly trips to the UK to be with the team in Cambridge. And I'm hoping that next time I can time it so I can sit in on a Pi Academy to see how it runs and see what's needed for it, and see how we'll adapt it for the US. The education team is also, I've been talking to them about bringing them out here to do a Pi Academy. There are a lot of different ways that there are a lot of possible ways that we can kind of get those resources out there, whether we bring it from the UK or we seed it here or something. We're figuring that out. I think we're going to try a few different things to see what works best.
I was just wondering, what programming languages and stuff like that might be used.
Usually like Python.
Okay.
Yeah.
Python What's the deal with this Model A for $20?
Yeah, so the Model A takes away the Ethernet port and 3 of the 4 USB host ports. So It's much smaller, has smaller footprint, much lighter. It still works with a HAT specification. It has the Broadcom 2835 on it. That's supposed to be the even lower cost Raspberry Pi if you want to use that as well. It would be great for smaller projects.
Yeah. And wasn't there like that memory card form factor at one point?
Yeah. And so that's still around. That's the compute module. So let's say you've made a project with Raspberry Pi and you want it to be a product. One way you could do that is by using the compute module, which uses a SODIMM interconnect on it. It basically has the Raspberry Pi, it's basically the Broadcom chip, the RAM, and some flash memory as well. So if you want Linux in your product, you can put this into your design, and it takes care of a lot of the hard stuff for you. So there are, like, for instance, there's a hackable camera called OTTO that uses the compute module. They had a Kickstarter that was a smashing success, and so I think they're starting to ship now. So every single one has a Raspberry Pi inside.
Right. Is that actually made? Is that actually made by you guys?
Yes. Yeah.
Oh, okay. So that seems to be against your focus on making an educational board. You've actually developed this compute module for sort of like commercial industrial applications.
Right. Yeah. And we found that there's all those people who do use Raspberry Pi beyond what Raspberry Pi is used for, what Raspberry Pi is intended to be used for. And so, they wanted to provide some kind of stepping stone so that projects that are based on Raspberry Pi that advance Raspberry Pi, that they had somewhere they can kind of graduate to without figuring out how to get into the world of putting an SoC chip onto a board themselves. So yeah, that you're right. That absolutely it does. It's kind of more of a play in the industrial area, but that was what's great about it is that every single compute module sold will benefit the educational mission of the foundation.
Yep, right.
Yeah, no, that's interesting. I was imagining like, well, I started with the Raspberry Pi, and then on the next day I was doing high-speed layout for a
yeah, right.
a DDR3. I don't know.
yeah, that's right.
Crap. No, that's really cool though.
Yeah, it's nice that at least that like we didn't want to ignore the people who were doing these incredible things with Raspberry Pis that could become products. It's certainly not meant for people who are going into super high volume because we don't allow the price breaks just don't work that way with us. Yep. It's cheap for everybody, not just some people. So the way I look at it is kind of a stepping stone on to like so that you could do maybe 5,000 of a product that is based on Linux using Raspberry Pi.
Yeah. So I would assume that you actually make a profit on that, which then supports your essentially non-profit educational focus.
That's exactly right.
Right.
Yep.
Yeah, because you have to get your money from somewhere. Otherwise,
right. Unlike charities that go out and seek donations, we just try to get people to buy Raspberry Pi because all the profit from that goes right into the foundation.
Yeah,
and supports
awesome.
it.
Yeah.
Of course, some of it goes. Obviously, some of it goes towards improving the product, and then a large portion of it also goes to the education side.
Yep.
It's interesting too. I wonder. I mean, has there been any talk with like the OLPC, the One Laptop Per Child foundation at all?
No. You know what? What's the deal with them? Are they still around?
I've been in contact with a guy that's doing something.
Oh yeah, okay.
Similar to that. I am not a fan of the One Laptop Per Child.
You're not a fan of the foundation or the actual hardware?
I'm not a fan of the concept.
Oh, okay. Well, I always thought it was a cool idea in terms of like. Well,
Ask me why.
Again, it's a similar idea of like broad access to computing and programming stuff like that. But Dave wants to say.
I want to say that these children in third world countries need clean water, education, medicine. Right? They don't need a freaking laptop, right? They need essential stuff to make them healthy and learn, not, like...
Well, I think it could go towards
a lot of these people don't... It's just a lack of...
I agree with the other stuff.
It's a lack of priorities, If you're going into these third world countries and you're given, here's a laptop, congratulations, look, and they're going, but my family's starving, I don't have fresh water, I don't, have, pens and pencils for my classroom. Like,
Yeah,
it just bugs me,
From a humanitarian side, of course.
Yeah,
that makes sense.
Exactly. Yep.
Yeah. No, but I know one of the things that they had struggled with was they were trying to get like sub 100 or something like that, and they had missed it once or twice. But I mean, I think it's interesting seeing, going forwards, this is the path of hardware, right? It's just these lower and lower cost things, and so this could kind of supplement that if they're, in places where there is hopefully, access to water and clean water.
Once they have all the
like
basics, then yes. Yeah. Once they have, basic infrastructure, then I'm a supporter of it. Absolutely.
Yeah, definitely.
Yep.
I had actually, I woke up from a dream the other night, and I started thinking about. So I teach contextual electronics. Now we're getting trippy. No,
where's this going here?
no. So I had taught. So I try and offer like. I suggest, common tools so that we're all on kind of the same basis. And, like the EX330 that Dave talks about in the $50 shootout, stuff like that, just like low cost but effective tools. And then I started thinking about, well, what happens now if you offer a common computing platform as well, right? Because there's always a lot of strife around computing of, it doesn't work on my version of Windows or Mac or Linux or anything like that. Obviously, KiCad has that problem as well. But then if you kind of standardize around a platform and it has enough computing power, right, like this upgrade to the Raspberry Pi 2.
You're talking about tools, right? You're talking about running KiCad.
Yeah, right. And Matt, you had mentioned to me that it does run on there well, right?
Yeah, that was one of the first things I tried. It was a pretty easy install. It loaded up. It felt really snappy. And so what I'm hoping to do is to be able to design a hat
nice.
expansion board using
Recursive
Raspberry
hardware.
Pi. Yes, exactly. Use Raspberry Pi to design expansion hardware for Raspberry Pi. Show people how to do it, and maybe you either mill the board yourself or you send it off to get manufactured.
I was going to say what it does
Yeah.
is it needs to talk to a milling machine and then talk to a pick and place machine.
Yeah.
Both of which have Raspberry Pis, right?
But-
Yeah. Well, I went to visit Other Mill. They make the. I went to visit Other Machine where they make the Other Mill, and that machine is incredible and really neat. And I was like, oh, how could we get Raspberry Pi running this so that we can go right from the CAD right to the mill and get those boards coming out?
Yeah, that's great. That would be really cool.
Yeah, I'd love to see that.
Yeah, so I mean, like, I was just kind of thinking about that around, like, and I put it out on Twitter, and a lot of people are like, "Oh, well, use this and use that," and I don't. It was the argument was not specifically for Raspberry Pi, but just the idea of having low cost common hardware. I mean, that's obviously the educational side of things, like you guys are working with. That's really important because you remove so much variation. Yes, people have to give up their choice on platforms, but sometimes you don't want that, and people were like, "Oh, my hardware, blah blah blah." I don't care, like when you're trying to achieve a goal like education, it can be really beneficial, and that's good because that's what you guys are trying to do. So
yeah, and it reminds me that we like one of the things that is out there is resources for doing bare metal programming with Raspberry Pi. People can use assembly to bring it up. And obviously it's really rudimentary. It's something I've been meaning to kind of play around with a little bit because I've always been kind of using higher level languages my whole life. I'd love to just kind of jump down and get in there a little bit. It focuses on how to write assembly that runs on Raspberry Pi, and that's great because so many people out there have Raspberry Pis and can try it out, and it doesn't need to be for a particular chip or whatever. It just, here's how to do it with your Raspberry Pi. I love that. I can't wait to try that myself.
Yeah, someone had mentioned that to me that there was a course there was an online course it was at Stanford maybe? I don't know.
I think it's University of Cambridge School of Computer Science has the bare metal course. I'm sure there are plenty of them out there.
Yeah. Excuse my ignorance on this, and maybe Dave will laugh at me as well, but you don't need to know anything about register sets or anything like that in order to do that bare metal programming? I mean,
you do. I was going to ask about that. How do you do the assembly language programming if you don't have the data sheet?
That's a good question. I haven't gone through the tutorial yet myself.
Or maybe you can get the program. No, but I thought the whole concern about the Raspberry Pi and the use of the Broadcom chipset is you couldn't get any information on it, let alone the actual physical, like the assembly, like the instruction set programming language. So I'm very curious to know how that's going to work, because Broadcom won't be a fan of that if they're.
Well, it'd be interesting for us if it was a hack.
It's ARM. It's ARM 7. Oh, God, what am I thinking? Yes, of course, it's the ARM v7. It should just work. But then you've got to...
that's the instruction set you need to know.
You're right.
That's what you're saying? Okay.
Yep.
Okay.
As opposed to like the I/O side of things is maybe different. But but as far as actually running code on the processor, it's just standard ARM v7. Of course it is. Duh.
Yeah, okay.
Yeah,
again, that was my lack of knowledge. I don't do assembly, so
me neither. Not yet. Yeah. But I know where to turn if I want to learn it, and I'm hoping to do that.
No, that's cool. No, and I think someone mentioned that Stanford or somewhere out West Coast is doing it as well. So,
cool. I'll have to look that up. So I do want to know what people are doing in that realm.
Cool. So any big projects planned for yourself? I mean, do you got anything in the hopper?
Right now I'm focusing on we're going to be going to South by Southwest.
Cool.
Interactive. We're going to have a nice presence there, I think. So I'm figuring all that stuff out now with some of the folks in Cambridge to figure out how we're going to what kind of fun activities we're going to do. We're going to have some
hands-on
barbecue
stuff. To go to.
Excellent. Yeah.
Salt Lake. Salt Lake
party. Yep. Oh yeah. We'll be at South by Southwest. We'll have a nice contingent from Raspberry Pi there where we can kind of really kick off our US presence. Even though we do it Maker Faire, they've done Maker Faire many years now.
Yeah. Well, that's great though. I mean, you're like the US beachhead for Raspberry Pi.
Yeah, it's great. It's a little overwhelming. I have to say, it's a little overwhelming, and there's a lot of work to be done. But Luckily, there was plenty of like really eager partners in the US who were just waiting for Raspberry Pi to have enough bandwidth to be able to like really like foster the relationship. So I came in and got a bunch of emails of people I should contact, and it's been great.
Well, I'm sure you will also get some emails from our listening audience. So or however you'd like to be contacted, how should people contact you?
Yeah, so I'm on Twitter, just Matt Richardson. If anyone wants to just have a casual conversation with me, but if anyone out there does have something passionate they want to talk about when it comes to Raspberry Pi, matt@raspberrypi.org is where they can email me about it.
He got the single name email. That's early.
Yes, nice.
I wish that's why,
right in at the ground floor of the company. That's no other mats allowed.
I wasn't sure if I wanted to join Raspberry Pi or not, and I asked, well, are there any other Matts there? They said no, and I said, so I can have matt@raspberrypi.org? They said yes, and so I said yes, I'll take the job.
Wow. That's great.
That's
your sole requirement for joining the company now.
What will my email address be? Before I say yes here.
How many shares of Raspberry Pi? It's a nonprofit? Okay, I'll take the email address.
Email address is fine.
Yeah. Well, Matt, thank you so much for coming on the show. We really appreciate hearing about the new stuff in the U.S. That's awesome. And
yeah, thanks for having me. This was a lot of fun.
Cool. Well, we'll talk to you on Twitter soon, I'm sure, and we'll look for more projects.
Thanks, mate.
Thanks a lot.
Catch you next time.
Thank you.